We were in Cork back in Valentine's Day. We got a high-level overview of the projects, and the idea of the bunch of learners we can dive into a little bit more detail today. So Ben and Ryan will talk to you about AC3.
How are you going, everyone? My name is Ryan Jenkins. That's Ben Capper. And today we'll be talking to you about the Agile and Cognitive Cloud Edge Continuum, or AC3. Don't ask what happened to round 2. Yeah, so before we get into the specifics, we should try to explain the proposal I thought we were talking about. So Agile, Cognitive, Cloud Edge Continuum, and federated infrastructure. Agile means a system that can adapt to changing conditions. Cognitive is the ability for the system to make well-informed decisions without human interaction. It is done through deep AI integration. The Cloud Edge Continuum refers to the range of environment options which system leverages from cloud data centers to IoT devices on the far edge and everything in between. And then federated infrastructure pulls together resources across different environments for shared use. And then Ben's going to talk about what is AC3.
Yeah, so essentially it's a federated cloud edge infrastructure with deep AI integration. So the AI is managing resources across a network of different computing environments in a platform agnostic way. And these environments can be everything from cloud to edge devices. So it won't matter if the clusters on each environment are from a different platform. The federation layer provides interoperability between them all. And it manages all aspects of an application's lifecycle. So this could be anything from storing and retrieving data to deploying and scaling microservices. And the network is configured both proactively and reactively through AI predictions. And then, of course, there's a big focus on sustainability. So microservices are deployed or migrated to the most efficient and green source of energy. So how do we know if the point of the project is actually being achieved? Well, it'll manage application life cycles and the actual cloud edge infrastructure automatically with a focus on green energy. It'll provide an integrated data management platform where developers can easily access their data or store their data. The federated model provides resource sharing, which enables distributed workloads, and the system will be able to onboard new environments, install clusters on them, and link with other clusters. So we'll just go through the architecture and the main components. So the first plane is the user plane. Developers manage and deploy their applications here. Then we have the app and resource management plane. So this intelligently connects apps with the right resources. And then we have the adaptation and federation layer. So this is composed of the actual computing environments where processing happens, like the cloud or the edge. So the main components of the user plane then. So this is where all the developer interaction happens. So the first point of entry is the northbound API engine. So this is listening for developer requests and it routes them to the corresponding services. Then on the left here, we have the service catalog. This makes it easy for developers to discover and integrate existing functionality. And it's basically a list of microservices and their descriptors. Then in the middle, we have the KPI collection and exposure. So this is constantly gathering metrics from the system to measure microservice efficiency and make sure that the data can be accessible by developers for any insights. And then we have the ontology and semantic reasoning. So this is translating human readable rules or policies, application descriptor, and this understands how microservices and the data they use are related and defines how the app should be managed and deployed. So in the middle layer, then we have the application and resource management plane. So this is the brain of the system. It has deep AI integration and it makes decisions based on the current and predicted state of the infrastructure and the apps running on it. So the first component here is the AI-based LCM. So this is using app descriptors to decide on initial placement of an app's microservices, and then it manages the resources and applications. So it can scale or migrate based on profiles and management. Then the application profiles are created by running AI and data analysis algorithms to provide information about the application's behavior, like trends, traffic, and performance. And the resource profile is created by is a profile based on the AC3 infrastructure itself. So this can be the available resources on each site, the types of energy used, the network links which connect the clusters. And then monitoring is used with resource and app profiles to provide insights for the LCM to make decisions. And then the decisions that the LCM makes are sent to the decision enforcement component, and this forwards those decisions to coordination layers adaptation agents, which then translate the request for a specific site. And then the final layer that we have is the adaptation and federation plane. So first components here are this layer provides integration and consistent policy enforcement across all the environments. So the adaptation gateway associates an agent with the local management system of the site's infrastructure, and this helps enforce the LCM decisions. And there's an adaptation agent for each infrastructure site, and these are responsible for translating the requests from the decision enforcement module into instructions that one of the sites here on the bottom can actually understand. So then we have the resource broker and discovery components. So the discovery component is collecting information on the available federated resources, and it monitors the endpoints to share and standardize resources with the broker. Oh, sorry. And then the broker chooses the actual appropriate infrastructure site based on the deployment's requirements and the resources it has available. And then at the bottom we have the actual sites themselves. And when a resource or microservice is actually being deployed, it'll be placed on the most green and efficient onboarded site. You know, that's a lot of architecture slides, probably blowing heads off everyone, but there's only a couple more. So this is the data management platform that's integrated into AC3, and these are the main components in it. So the catalog is storing metadata like data structure and location, and this allows for discovery and increased data understandability. The federation services combine data from different sources and provides a unified access point to multiple disparate data sets. The manipulator is processing data with functions like format conversion, validation, cleaning, that sort of thing. Then we have the brokers, which are routing the data between the components of the management platform, just to make sure everything is going to the right place. And then we have data mappers, and these are transforming and mapping the data into a format that's actually understandable by the system. And this can involve adding more information, converting data structures, that sort of thing. And then finally, we have the data source connectors, and these are acting as the bridge between the external data sources and the actual data management platform itself. So we have a complete architecture here, so I'll just quickly go through how an application might actually work on the infrastructure. So the first thing that happens is the app performance requirements and key performance indicators are defined and given to the system. The ontology and semantic router makes an app descriptor which can be used for the initial deployment. And then so the LCM then, the lifecycle manager, is using the descriptors as well as the resource and application profiles to make decisions about where to deploy the microservices. And it decides on appropriate things like scale, not migrating whenever these need to happen. Then we have the decision enforcement module, which is, like I said earlier, is going to send or forward the decisions made by the LCM down to the next layer, which is the adaptation gateway. But the management system is keeping track of real-time performance data for all of these components the whole way through. Then we have the adaptation gateway. The adaptation agents at the gateway apply these decisions by translating requests to the actual sites that microservices are deployed on cannot actually understand, and resource discovery and broker and allocating resources to the correct things, I suppose. And then microservices are finally deployed on the infrastructure sites at the bottom. And throughout the whole process, the data management platform is being used to make sure that the microservices have consistent and reliable access to all the data that they need. So pass you over to Ryan.
Yeah, I'm going to talk about RedHat's role now. Oh, that's wrong. Let me fix that. Much better. Ooh. No idea what practice went into that. So network programmability. So to give a quick definition, we proactively and reactively configure the network to meet AI predicted requirements and solve unpredicted anomalies. So we're going to focus on the interconnectivity between clusters and disparate environments, optimize the flow of data, ensure applications meet SLAs or service level agreements, and make efficient use of green energy. So we're going to provide efficient coordination between microservices by adjusting network routes and resources based on current and future requirements and conditions. So I'm just going to go quickly over the network programmability diagram or architecture we're following. You can't really see that, that's not a great diagram, but sure, look, I'll read anyway. The adaptation layer, so that's the top here, sends instructions from the LCM to the infrastructure sites through a northbound interface on the LMS or a local management system, which interacts with Kubernetes API in the federation control plane. Yeah, so the control plane also leverages the AC3 network, AC3 network operator, such as which will install Submariner or Scupper. These operators can now be placed on a host of multiple Kubernetes clusters in order to link them together. And then if Kubernetes is not available, we'll use SD1, the SD1 network overlay, which is orchestrated by a central controller. Oh, next one, yes, sorry, thanks, Ben. Network overlay, which is orchestrated by a central controller and can be used for to collect the non-Kubernetes environments with a higher level of control, such as Scupper or Submariner. And then once multiple clusters are linked, linked, the pod and services can communicate with each other on different clusters. Yeah, so to go over the network programmability tools that we're going to be using, so Scupper, Submariner, Netscaler, and everyone. So just to say before as well on the diagram that the architecture hasn't fully clamped down on yet, but these are just the technologies that we'll be using. We may not end up using all of them. So yeah, Scupper creates a routing component or a namespace traffic from one cluster to another. Submariner enables pods in different clusters to communicate with each other at a network level rather than an application like Scupper. Netscaler performs application-specific traffic balancing to distribute, optimize, and secure layer 4 to layer 7 network traffic. And then everyone is an open source version of SD1 and dynamically manages and optimizes network traffic, provides secure, reliable, and efficient connections between clusters, and fine-grained control over the network. And then to go a little bit more detail of Scupper, it provides us the inter-cluster connection between two Kubernetes clusters, which allows services to be deployed and communicate with services on another cluster. The benefits of this are simplified networking, scalability and resilience, flexibility, and security. And talk about Submariner here. Submariner is an open source project tailored for Kubernetes clusters. It establishes encrypted tunnels between nodes in each OpenShift cluster, creating a secure connection pathway. Dynamically manages the routing network traffic between two clusters, allowing applications, services deployed in one cluster to seamlessly interact with those in another. And once we set that up, the techniques are fairly similar to do on the other one. It's looking like we're going to have to get established with ACM in order to implement what we actually want to do. And no, Dean, you can't poke the head off. To show what we've done so far, so the current Jasper implementation. So we have two single node clusters installed on the ICS cloud. Scupper installed and configured on both. Netscaler deployments are being configured and full access given to Citrix in implementing Netscaler. So our OpenShift operators, our future hopes are to build an OpenShift operator that will extend to Scupper and Submariner. This will fast track our progress and establish in the architecture. We'll then install ACM onto an OpenShift cluster and then deploy Submariner that way. And now it turns out we may not end up needing Scupper, but like I said, it's still being investigated. And then the testbed and partner setup partner support, sorry. In order to set up our cluster, RCS allowed us to use our cloud infrastructure. The process to complete this led us to creating a custom ISO image, which helped us make the cloud server. Once we set up the cloud server, we were able to install OpenShift onto our cluster using the system installer. And then we were able to set up the Scupper connection between two clusters. We're currently working with Citrix actually to set up a net together over two clusters, and we just have to give them full access. So the timeline of the project, as you can see there, we've something called in April with the architecture design to finalize hopefully by the end of that month. And then the rehearsals is the main one as well in June, and that's where we're going to be showing them the complete architecture and kind of demo it for them. So use cases then, I'll pass back to them.
Yeah, so we have a couple of use cases. The first one is map management. So I'll quickly go through the tech stack that's being used for that. So it starts with GStreamer, which is an open source multimedia framework which manages the video pipeline from the feed to output or storage. On top of that sits DeepStream SDK, which is an AI-based video analytics platform that uses deep learning models. So a few of these models that we're using are PeopleNet, which recognizes people, Action Recognition Net, which classifies actions, and RetinaNet, which is used for object detection. And then finally, we have the MB Tracker plugin, which assigns a unique identifier to any objects in a frame on the first frame of the feed, and then it'll track those objects throughout the rest of the frames. And this helps analyze trajectory and behavior of an object. So how AC3 enables this use case. So on the right there, we have a camera on the far edge. So the edge camera streams video and sends it to a server at an onboarded infrastructure site. And on this site, there's containerized deep learning models deployed and able to use to process the actual feed. And then once that data has been processed, it can be sent to the ACCC data management platform, and it can be stored and retrieved through this, and it can be processed further, analyzed further, or accessed by applications for use. And the second use case, then the one that RedHat is actually in charge of, with UCM, which is the University of Madrid. So in this one, there's hundreds of terabytes of astronomy data that need to be processed that are in like these data cubes. So algorithms and functions to process these complex cubes are containerized as microservices, and then these can be deployed on the AC3 infrastructure. And then the infrastructure can then orchestrate and optimize the resources based on the actual computational needs or the workload demands. And then finally, processing happens in a distributed way. So slices of a workload can be processed by different nodes across various different sites. And then the results can be stored in a common repository.
Yeah, so just go over the communication dissemination on the project. There's just 3 events that took place. That's us talking in court a couple months ago. And then the 2 lads for the AC3 project in Greece, just advertising it. And then the bottom pictures galleries that we had in Barcelona.
Just a bit of shameless self-promotion. I have a blog as well if anyone wants to read it.
Yeah, so the next steps.
Yeah, so the next steps really focus on our role on network programmability and dissemination and open source activities. So we need to finalize the network architecture, and we're working with partners to do that at the moment. Once that's done, we can create an AC3 network operator, which is going to install and manage other operators like Submariner or Scupper. Then we're going to actually build the proof of concepts to show how ACM and Submariner can be actually used to connect a multi-cluster environment across a range of disparate infrastructures. We're going to work with the University of Madrid to support them in deploying workloads for the observatory use case. And one of the big parts that they want to see from Red Hat is contribution to open source activities. So this could be contributing to things like Kubernetes, anything that has a relevance to the actual project. And finally, dissemination. So we plan to do talks like this, content and papers around the project, just to increase this project, the visibility. And then obviously attend events to showcase any innovations.
That's just the AC3 consortium there. That's all the partners on the project. You might recognize the names just from the technology space. We're actually in quite interesting. RCS, INOS, and Citrix are actually past sponsors of Red Bull in F1. So that's pretty cool. And yeah, so the summary just what we covered. So the project architecture, the Red Hat role, network programmability, and the future plans of the project. And that's the Waterford Research Interest Group of the team. We're all working on EU research projects. So there's AC3, Encode, and Code. And Green Dot.
Most of the time went into that, yeah.
And yeah, any questions?
Yes, so if anyone has any questions, we'll try and answer them.
Go back to this slide.
No questions?
Hopefully.
Any questions from online?
Sorry, that was some mind-boggling stuff. Great job in the presentation, guys. I just wanted to ask if you could share the slides maybe after this.
Yeah, definitely. Perfect.
Thanks very much.
Nice.
Okay. Thanks very much, lads. Bit of some